Okay, the continuous function f, so continuous function f is defined on the closed interval -6 to -5. This is also f. Interesting. So they said -6 to +5, so they're not showing everything. The figure above shows a portion of f. Got it? Just keep reading. 2 line segments and a quarter of a circle. Well, that's helpful. 2 line segments, quarter of a circle, center of the point 5, 3. So the center of the circle is right here. Yep, I can see that. This is the radius of the circle. So I'm good there. Okay. It is known that this point is on F. 3.3 comma, and oh wow, that's interesting. 3 comma 3 minus root 5 is on F. So 3, so this point right here, 3, this is F. So this point is right there. Okay, keep reading. If this integral is equal to 7, write that down because that's a little confusing because they start at -6. That integral is equal to 7. We're supposed to find this integral, which basically says we're supposed to be able to figure out, that's a negative, figure out what the integral is for this space we can't see. There is a concept that gets tested more regularly on the multiple choice, so we haven't practiced it as much this year. It's a simple idea. We did talk about it a little bit before the dismissal. The idea that the integral, it's really simple, the integral from -6 to -2 of f plus the integral from -2 to 5 of f must equal the integral from -6 to 5 of f. We're trying to find this integral here. We know this integral's value is 7. So if we go find this integral's value, we'll know this integral's value, which is what we are seeking. So I'm going to do that now. So I write on my paper the integral from -2 to 5 of f, and this is something we have practiced heavily on the practice tests. This is the graph of f, so I can use area to find this blue integral. Got to be a little careful. Starting at -2, this portion of f is definitely positive. That's 1 times 1, and it's a triangle, so that's a half. Then, moving on, this portion of f is now negative, so that counts as negative a half. This portion is also negative. That's going to be minus. It's 1 times a half times another half. It's a fourth. But I can leave it like that. Then this portion of f is definitely positive. It's 3 high by 1.5 wide, so plus 3 high, 1.5 wide, all divided by 2 because it's a triangle. Then I've got to get this last piece over here. This is all, here f is all positive. So what I do is note that there's a square here that is 3 by 3. So plus 3 times 3, that would be the area of the square. And then I subtract from the area of the square the area here, which is a quarter circle. That's going to be minus pi. Radius of that circle is 3 squared. That's the area of the circle. I take a fourth of that. So by taking the area of the square and subtracting the area of the quarter circle, I get the area I need here to finish solving the integral. So that big mass is the value, this big thing here, that's my value for this integral. So only one more thing to write down. 7 subtract this integral's value will be this integral's value. So I write on my paper the integral -6 to -2 of f dx is going to equal, okay, the 1/2 and the 1/2, those definitely add to make 0. This is -1/4. Remember, I've got to take 7, subtract everything. So 7 minus, put a parenthesis so I don't mess up here, -1/4. I can just write this down as is, no need to stress about changing anything. 3 times 1.5, all divided by 2, plus, I guess I can do 3 times 3 is 9, that's pretty easy, minus pi, 3 squared is 9, all over 4, close parenthesis, that's it. So that will give me the correct answer. Okay, the way they gave points on this thing is they gave 1 point if they could see in your work that you figured this out. If you didn't write it out, I still think they'll give you the point, as long as they can tell from your work that was the work you were doing. If you found this integral, the blue one here, so all of this right here, that was 1 more point. Then if you have the final answer, which is this box right here in green, they gave you a 3rd point. So a total of 3 points on that problem.